suppose humanity survives for another 1,000,000 years. Our descendants may build starships faster than anything we can imagine today, computers powerful enough to simulate entire solar systems, and energy sources that make modern civilization look primitive. Would that finally be enough to conquer everything in the universe? Probably not, because some barriers are not caused by weak technology, limited fuel, or fragile human bodies. They are written directly into the structure of reality itself. These are not just the biggest numbers in physics. They are 8 cosmic boundaries that decide how matter, energy, time, black holes, and the universe itself are allowed to behave. And the final limit does more than stop us from traveling farther. It may place most of the universe permanently beyond our reach. Number 8 is the Chandrasekhar limit. A white dwarf is the dense core left behind after a star like our Sun runs out of fuel. Fusion no longer supports it, but gravity does not immediately crush it because electrons create a quantum pressure that holds the star up. But that defense has a limit. As a white dwarf approaches, roughly 1.4 times the mass of the Sun, electron degeneracy pressure can no longer maintain the same stable structure. What happens next depends on the star's condition. It may collapse further, or runaway nuclear reactions may tear it apart in a supernova bright enough to briefly outshine an entire galaxy. Even a dead star has a red line it cannot safely cross. Number 7 is absolute zero. Absolute zero is 0 Kelvin, or minus 459.67 degrees Fahrenheit. It is the lowest temperature allowed by thermodynamics. We can cool a system closer and closer to it, removing more and more energy. But the third law of thermodynamics says we cannot reach exactly 0 Kelvin through any finite physical process. And quantum mechanics makes it even stranger. Matter does not simply become perfectly frozen and motionless. Even in its lowest possible energy state, a system can retain zero-point energy, a kind of residual quantum activity that cannot be removed in the ordinary way. Absolute zero is not just extreme cold. It is the boundary where thermal motion is pushed toward its final limit. Number 6 is the Heisenberg uncertainty principle. There are properties of the universe that cannot be known with unlimited precision at the same time. The more precisely we determine a particle's position, the less precisely we can know its momentum. The more tightly we define its momentum, the more uncertain its position becomes. This is not because our microscopes are too weak. It is not an engineering problem that a future civilization can solve with better sensors. The uncertainty is built into quantum mechanics itself. At the deepest level, reality does not allow every detail to have unlimited simultaneous precision. The universe cannot be made completely transparent to the observer. Number 5 is the Planck scale. The Planck length is approximately 1.6 times 10 to the negative 35 meters, a scale so small that ordinary comparisons almost lose their meaning. Some people call it the smallest pixel of space, but science has not proven that space is actually divided into tiny Planck-sized blocks. The real mystery is more serious. At this scale, the quantum effects of gravity should become impossible to ignore. Yet general relativity and quantum mechanics have not been fully united into a tested theory that can describe what happens there. General relativity explains gravity and space-time. Quantum mechanics explains particles and probabilities. But at the Planck scale, these two great pillars of physics collide. To understand this domain, we need a complete theory of quantum gravity. We do not have one yet. The Planck scale may not be nature's final boundary, but it marks the edge of where our current theories can be trusted. Number 4 is the event horizon of a black hole. The event horizon is the ultimate point of no return. Once matter or light crosses this boundary, no signal from inside can return to the outside universe. This is not because the object needs a stronger engine. It is not because the escaping light becomes too weak to detect. Inside the horizon, every future-directed path through space-time leads deeper inward. The geometry itself prevents escape. From the outside, we can study the black hole's shadow, the warped light around it, and the superheated material falling toward it. But information that has crossed the event horizon cannot simply send a message back. It is the most extreme one-way door known to physics. Number 3 is entropy. In an isolated system, entropy tends to increase. In simple terms, usable energy spreads out, and organized states become harder to restore without outside intervention. A glass can fall and shatter, but its fragments do not spontaneously leap back onto the table and rebuild the glass. Smoke spreads through a room, but it does not naturally gather itself back into a cigarette. Heat flows from hot objects to cold ones, not the other way around. Living organisms can create local order, but only by consuming energy and increasing entropy somewhere else. That is why perpetual motion machines cannot work. That is why no heat engine can convert every bit of thermal energy into useful work. Entropy gives the macroscopic world its arrow of time. It is one of the reasons the past feels fixed and the future feels open. Number 2 is the speed of light. In a vacuum, light travels at exactly 299,792,458 meters per second. To us, that sounds unbelievably fast. But in physics, it is much more than speed. For any object with mass, the closer it moves to light speed, the more dramatically its required energy and momentum increase. Reaching the speed of light itself would require unlimited energy under special relativity. This makes light speed more than a limit for spacecraft. It is a boundary for information, cause, and effect. No known object with mass can simply accelerate past it through ordinary space. And if information could move faster than light in a normal local sense, the order of cause and effect could begin to break down. The universe seems to protect reality from that kind of paradox. But even light speed is not the largest prison, because there are regions of the universe whose future light may never reach us at all. Number 1 is the cosmic event horizon. The universe is expanding, and observations show that this expansion is accelerating. Because of that acceleration, sufficiently distant galaxies may lie beyond a boundary from which light emitted today, or in the future, will never reach Earth. Not because our telescopes are too weak, not because cosmic dust blocks the view. The space separating us from those galaxies is expanding in a way that permanently removes them from future communication. They are not locally flying through space faster than light. Space itself is stretching, and beyond a certain point, that stretching wins. Even if humanity survives for millions of years, even if our ships travel close to light speed, our descendants may remain trapped inside a finite cosmic island. Those distant galaxies will not cease to exist. They will simply disappear from everything we can ever reach, influence, or receive information from. That may be the most haunting limit of all. Not everything that exists can be touched. Not everything that is real can be reached. These 8 limits are more than technological obstacles. They form part of reality's framework. Absolute zero limits cold. Light speed limits information. Entropy gives time a direction. Stellar mass limits decide the fate of dead stars. Black holes hide regions behind event horizons. The Planck scale pushes our theories to the edge of knowledge. And the cosmic horizon reminds us that existence does not guarantee accessibility. Perhaps humanity's greatness will not come from breaking every boundary, but from traveling as close as possible to those walls and understanding why they are there. Which of these 8 limits makes humanity feel the smallest?